Hello there gang, welcome back to another epic inexorable maths video. In this video we're looking at in my opinion, very cool trig identity. We want to prove that arctan x plus arctan 1 over x is given by this piecewise definition of pi over 2 if x is a positive number and minus pi over 2 if x is a negative number. We can see that it's going to be undefined if x is the number 0 because we've got 1 over x there, 1 over 0. Can't do 1 over 0, definitely can't do arctan of 1 over 0, so this is its definition. This is how it goes. So how are we going to prove this? I've actually got a very similar video where I prove another trig identity using the same principle that I will leave a link to in the description to this one. But the way we're going to do this is really, really cool. So we're actually going to define a function. Let me underline this so we can see where the actual working out begins. We're going to define a function. I'm going to call it f of x, and it's just going to be this, arctan x plus arctan of 1 over x. Okay, so arctan x plus arctan inverse tan of 1 over x. This is my function f of x. Now, what I'm going to do is differentiate it. Okay, you might say, whoa, we're doing trigonometry. Why are you differentiating it? You shall see. So arctan has a standard derivative that you probably should know. If you don't know it, it's okay. I'll also leave a link in the description below to the derivation of why the derivative of arctan is what it is. But arctan differentiates to 1 over 1 plus x squared. That's the derivative of arctan. Now, by the chain rule, the derivative of arctan of 1 over x is as follows. So 1 over x, that's x to the minus 1, that differentiates to minus x to the minus 2. And then we need to differentiate arctan. So that's going to be, and I'll put it in brackets, 1 over 1 plus, and it's not going to be x squared, it's going to be 1 over x squared. Okay, so this is just the chain rule, okay? It's a bit of a complicated chain rule, but it is the chain rule. If we simplify this, you're going to see something very cool. So rewriting 1 over 1 plus x squared. And then what have we got here? So let's do a little bit of simplifying. So we've got x to the minus 2. I'll leave that there. Actually, I'm going to put it on the top of the fraction. So x to the minus 2 there. Okay, and what's going on here? So we've got 1 plus, and then actually this here is x squared, isn't it? Or at least it's 1 over x squared, which can also be written as x to the minus 2. So we've got 1 plus x to the minus 2 down there. Hopefully that makes sense. And if we multiply the numerator and denominator of that second fraction by x squared, okay, so timesing the top and the bottom by x squared, so times x squared, you can see that actually this whole thing here becomes 1 over x squared plus 1. Does that make sense? And we've got the same thing here. We've got 1 over 1 plus x squared minus the same thing. Obviously, 1 over x squared plus 1 is the same thing as 1 over 1 plus x squared. So actually, this and this cancel out because they're the same thing, which means that the derivative of this function that I've made up is actually 0. Now, when this happens, it's super, super useful because if we just use the ideas of differentiation and integration, if I integrate this derivative, I, in theory, will get back to the original function, but just with a plus c. So this implies that the original function f of x must be some constant, or it must be constant everywhere. Now, there is a subtle difficulty with this because we can find out what the constant is, sure, but the constant is not necessarily the same constant everywhere. All we know is that the gradient of the graph is always 0, but it is feasible that we could have a function that kind of looks like this or something like that. So flat, 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 equal to a constant number, flat, 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 gradient 0 everywhere, derivative 0, but different constants depending on where you are. This can happen, and it turns out it does happen in this question. So the only place where the constant can change definition is where there is a discontinuity. So we see that the only place where this function, arctan x plus arctan of 1 over x, is undefined is when x is 0, okay? So let's check two numbers, one to the left of 0, one to the right of 0. And those will give us all of the numbers that we need, okay? So the original function, f, of, let's choose a simple number. You can choose any positive number you want, but let's just choose a simple number like the number 1. F of 1 is arctan of 1 plus arctan of like 1 over 1, right? So just 1 again. And you might know that arctan of 1 is pi over 4, and we're doing pi over 4 plus pi over 4, that's pi over 2. Okay, lovely stuff. So f of 1 is pi over 2. And let's do another very simple number that's less than 0. Let's do f of minus 1. That's going to be arctan of minus 1 plus arctan of 1 over minus 1, so, minus 1 again. And again, you might know the arctan of minus 1 is minus pi over 4. So overall, this gives us minus pi over 2 because there's two of them adding together there. Now, as I said earlier, because f of 1 is pi over 2, because it's a constant everywhere, that means that f of any positive number is pi over 2. And because f of minus 1 is minus pi over 2, that means f of any negative number is also minus pi over 2. It can't jump around because there's no discontinuity. These functions are continuous everywhere except for when x is 0. The explanation there is slightly more complicated than, I guess, the scope of the rest of the video, but just take my word for it or use Desmo's. You can see that the graph is going to basically look like this. That's kind of what it's going to look like. And this is pi over 2, and this is minus pi over 2, and there's a discontinuity there and there. Like it's not defined for 0 when x is 0. So that is the idea behind the cool trig identity. And I mean, that's the idea, that's the concept of the video, but stick around if you want to see a little extra. Okay guys, we are going there. We're going to prove as a little extra that sine squared plus cos squared is always equal to 1. Now, this is by no means the easiest way of doing this. It is not the most obvious way of doing this, but it's just fun. It's just a bit of fun. Look at me getting riled up. So, how are we going to do this? We're going to do the same concepts. So, I'm going to say that f of x is this function sine squared plus cos squared. Okay, and then I'm going to differentiate it. So the derivative of this function is, now again, we have to use the chain rule. Remember, the way that you differentiate sine squared, you've got to imagine it as sine x and then squared. So the 2 comes down, 2. Derivative of the inside is cos, sine differentiates to cos. And then we take 1 off the power and rewrite the original, so sine. Okay, so it's 2 cos x sine x. Then how are we going to differentiate cos squared? Same thing. So the 2 comes down, so we've got plus 2. The derivative of cos is minus sine. So I'm actually going to just save myself a little bit of brackets here, and I'm just going to put the minus there. Sine x times, and then the original cos x. Now, you can see that once again, we've got the same thing. 2 cos x sine x minus basically 2 cos x sine x, right? Obviously, the order of the terms do not matter. So the derivative of this function is once again 0, big fat 0. That means that the original function, because we're integrating it, the original function, 0, integrates to a constant. So the original function is a constant. Now, there are no discontinuities at all on sine squared plus cos squared. So it won't take 2 different values or 3 different values. It will only take 1 value. So all we have to do is choose any number we want. Could be 0. Maybe that's the easiest one to do. and see what it is, and that's what sine squared plus cos squared will always be. So let's just choose 0 because it's probably the easiest number, but you can choose any number you want and this will work. I'm going to do f of 0, and that's going to be sine squared of 0, which is 0, plus cos squared of 0, which is 1 squared, so 1. So 0 plus 1 is 1. So f of 0 is 1. Because we've shown that the function is a constant, it's always the same constant, that means f of x, f of anything, is always 1, which means that this is always 1, okay? And that's how it is done. So guys, thank you so much for watching. I highly appreciate it, as always. And yeah, I'll see you in the next video. Friendly reminder, you will never ever see a mid-roll ad on this YouTube channel. I do not want people coming to my YouTube channel and then having to get interrupted by an advert in the middle of the video. Gross, icky, we don't like it. So if you ever see a mid-roll ad on my channel, ever, leave a comment in the video and I will happily come in and rinse the mid-roll ad, okay? I will take away its health insurance. So thank you guys so much for watching. Highly appreciate it. I'll see you in the next one. Cheers.